constant, more classically or mathematically called as a scalar. So we call this matrix as a, which matrix? Scalar matrix. Clear? So what is the definition? What is meant by a scalar matrix? We say a scalar matrix is a diagonal matrix in which all the principal diagonal elements are equal to a constant. What we say? A scalar matrix is a diagonal matrix in which all the principal diagonal elements are equal to a constant. Okay, and such matrix is known as a scalar matrix, and we said the simple. Okay, nobody will ask why it is known as scalar matrix, but it is better we try to understand. We said the reason for calling it as a scalar matrix is the principal diagonal elements are all equal to a constant, and constant in mathematics is more categorically or classically known as scalars. So it is a scalar matrix. Okay, now, so we discuss scalar matrix. Now we come to the sixth one, known as unit matrix. Okay, and this is also known as identity matrix. Identity matrix. Okay, so we come to unit matrix. So the last one we have discussed is scalar matrix, and we have seen scalar matrix is a, we are writing a scalar matrix again. Scalar matrix is a square matrix, thereafter it is a diagonal matrix, and in the principal diagonal all the elements are same. Okay, and now the thing to remember is when I come to the diagonal matrix, all the elements other than the principal diagonal elements are 0. So we are considering, or we are getting non-zero elements in the principal diagonal. Clear? So in a diagonal matrix, non-zero elements in the principal diagonal. If all these non-zero elements are same, that is a scalar matrix. So anyhow, in a scalar matrix, what are the principal diagonal elements? Same non-zero elements. For example, if you take 2, all the principal diagonal elements are 2. If you take it as -3, all the principal diagonal elements are -3. If you take it as 5, all the principal diagonal elements are 5. Means non-zero real numbers. Same non-zero real numbers. Okay, just think of non-zero real numbers. How many are there? Yes, there are infinitely many non-zero real numbers. Among these infinitely many non-zero real numbers, suppose we want to make a special choice. We want to take a real number as a special one. Then of course, as it is a special choice, we have to find out some speciality to this number over the other numbers. Can you say any such special number among the infinitely many non-zero real numbers? Which is the most special number among the infinitely many non-zero real numbers? Okay, it is nothing but the real number 1. Among the infinitely many non-zero real numbers, 1 is the special number. Then of course you may ask the question, sir, what is the specialty for 1 over the other numbers? Answer is very clear. That is a simple fundamental of mathematics. We know that basically there are two fundamental operations in mathematics. Lower classes we studied 4. Thereafter, I think that in the last year class itself, I said no need to consider 4 operations at this level of mathematics. From that 4 fundamental operations we study in lower standard, we come to basically or actually 2 fundamental operations, namely addition and multiplication. And I said subtraction is a kind of addition. So no need to consider subtraction as a different fundamental operation. Then I said, or as we said, division is a kind of multiplication. 3 by 2, of course a division, but 3 by 2 is nothing but 3 into 1 by 2. 3 into 1 by 2 means what? The multiplication of 3 and 1 by the multiplication of the real numbers 3 and 1 by 2. So what does it mean? Division is a kind or type of multiplication. So fundamentally we have 2 operations, addition and the multiplication. And for multiplication, what is the identity element? 1. Okay, that property of 1 makes 1 special, unique, different from the rest of the non-zero real numbers. Here, so which is the most special non-zero real number? 1. And in the diagonal matrix, we take this 1 as the principal diagonal elements. 0, 0. Clear? So matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 is a scalar matrix because all the principal diagonal elements are equal to a scalar 1. Okay? And this matrix is specially categorically known as unit matrix. It is also known as identity matrix. Okay, identity. The first letter is capital I, so usually we use the letter capital I to represent such a unit matrix. So what is unit matrix? Matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. An example, and what is the definition? A unit matrix is a diagonal matrix. If you are saying in terms of diagonal matrix, a unit matrix is a diagonal matrix in which all the principal diagonal elements are equal to 1. Okay, now a simple question. Because many a times we say the reason for the name. The reason for a particular name is given in the name itself. What is the name of this matrix? Unit matrix. And for this matrix we have seen the speciality. What about the principal diagonal elements? 1. So why it is known as, why it is specially called as a unit matrix? Okay, which are the principal diagonal elements? 1. 1 means 1, we know 1. 1 means unity. No doubt. 1 in mathematics is also known as unity. For example, in complex number, we studied find the cube roots of unity. Instead of saying find the cube roots of 1, we said find the cube roots of 1. Sorry, find the cube roots of unity. Otherwise, we said 1 omega, omega square are the cube roots of unity. Okay, so what are the principal diagonal elements? 1. 1 means unity, and unity simply known as unit. So this matrix is known as unit matrix. Okay, and later on when we study matrix multiplication, we will study that the identity element or the identity matrix for matrix multiplication is unit matrix. Since it is the identity for multiplication of matrices, this matrix is also known as identity matrix. Look, 1. The identity of multiplication of real numbers. But I, the unit matrix, it is the identity of multiplication of matrices. What is the identity of matrix multiplication? So it is known as identity matrix. Okay. Now the other thing to remember is, even though I is the standard symbol for representing a unit matrix or identity matrix, depending on the order, we can specify that order in the suffix of I. For example, this is an identity matrix of order 3. So we can write it as I, or more categorically or specifically we can write it as I3. And if we are considering matrix 1 0 0 1, this is again an identity matrix or a unit matrix containing what, 2 rows and 2 columns, so I2. Okay, so this way we come to which one? Unit matrix or identity matrix. What is meant by unit matrix? It is a diagonal matrix in which all the principal diagonal elements are equal to 1 or unity or equal to 1, that is enough. Then why it is known as a unit matrix? Because the principal diagonal elements are all equal to 1. 1 in mathematics is also known as unit. Is given A 3 k plus 1. What does it mean? The row number is 3 and the column number is k plus 1. Make it clear? Row number is 3 and the column number is k plus 1. It is given A3k plus 1 is a diagonal element. Now the question is, if it is a diagonal element, then what should be the value of k? Quite clear? What is A3k plus 1? It is a diagonal element. Since it is a diagonal element, what about the row number and column number? They are equal, so no doubt. Therefore, 3 is equal to k plus 1. So k equal to 3 minus 1, 2. Clear? So this way, we can correlate the row number and column number of a principal diagonal element. Okay, so what we have discussed now? We discuss a square matrix, thereafter the principal diagonal, then the minor diagonal, and thereafter the diagonal elements. Okay. Now in the classification, we have discussed 3: row matrix, column matrix, square matrix. Now we come to the fourth one, that is a diagonal matrix. Okay, we come to diagonal matrix. So as we did so far, it is better to explain with an example. Okay, I consider a square matrix of order 3. Okay, 2 0 0 0 minus 1 0 0 0 5. Okay, so what is given? A matrix A is given. Now my first question is it a square matrix? Yes, because it has 3 rows and 3 columns. Okay, so we have considered a square matrix of order 3. And since it is a square matrix, we have seen it has equal number of rows and columns, namely 3. Now my question is, can you see any more speciality to the elements of this matrix? Or can you see any speciality to some elements of this matrix in comparison with a general matrix? Okay. Now what I am asking, which are the principal diagonal elements? Which are the principal diagonal elements? Okay, which are them? 2, -1, 5. No doubt. Okay, just take the principal diagonal elements. 2 minus 5. 2 minus 1, 5. Taken? See the rest of the elements. The elements above that 0, 0, 0. All are 0. The elements below that 0, 0, 0. Okay? And this is what the speciality I was asking for. Okay? So what about this matrix? It is a square matrix speciality for which all the elements except means other than the principal diagonal elements are zeros. Okay? What about this? This is a square matrix for which all the elements except the principal diagonal elements are 0. In such case, we say A is a diagonal matrix. So what is a diagonal matrix? A diagonal matrix, is it a square matrix? Yes, it is a square matrix. And thereafter, for which all the elements except the principal diagonal elements are 0. Okay, once more I say the definition. A diagonal matrix is a square matrix for which all the elements except the principal diagonal elements are 0. Okay. Now, since all the elements except the principal diagonal elements are 0, this diagonal matrix A can also be written in a simple way. Diagonal, okay, matrix symbol 2 minus 1, 5. What does it mean? A is a diagonal matrix with the principal diagonal elements, because it is very clear. In a diagonal matrix, the elements other than the principal diagonal elements are 0. The meaning is what? No need of bothering about the elements other than principal diagonal elements because they are zeros. So we must only know which one? The principal diagonal elements. So and sometimes we can write diagonal complete. Okay, matrix 2 minus 1, 5 is a diagonal matrix. Okay. Now, so from which one? Diagonal matrix, we come to the which one? Fifth one. We come to another type of matrix known as scalar matrix. What is that? Scalar matrix. Okay, just before going to the meaning or definition of scalar matrix, whenever we come to a mathematical term, just make it out. Whether we know it already or not. Means whether the terminology, the term is familiar to us or not. What is the term coming here? Scalar. Look, as soon as the term scalar we hear, what comes to our mind is the physical quantities, namely scalar quantities and vector quantities. And we just studied quantities having only magnitude are known as scalar quantities, and quantities having both magnitude and direction are known as vector quantities. So anyhow, no need to go in detail now because that is not our business. There is a thing coming in physics. Okay. So anyhow, scalar means what? Magnitude. Magnitude means, actually when you come to the magnitude, means it is absolute value. Clear? An absolute value of a quantity is a constant. It's a fixed number. So mathematically, scalar means what? Actually, simply in mathematics, scalar means, say, a real constant. As we are dealing with real numbers, it's a real constant, so a real number. Okay, keep it in mind. Okay, scalar matrix. That too we just explain with an example. We consider a matrix A, and that is a square matrix. So equal number of rows and columns. We take 3 rows, convenient 3 rows, 3 columns. We can go for any number of rows and columns, for convenient 3 rows and columns. So taken a square matrix. Now we are taking not only a square matrix, we are taking a square matrix that is a diagonal matrix. Okay, diagonal matrix means here that elements will come. The other elements are of course which one? 0. So anyhow, okay. Here also 0, here 0, 0, 0. Now, which elements are left out? Yeah, the principal diagonal elements. Okay, principal diagonal elements. You can write any numbers other than 0. The previous case you had taken -175, something like that. And here I am taking it as, for example, 3. This also 3, 3. My first question. Is it a square matrix? Yes. It's a square matrix because equal number of rows and columns. Second question. Is it a diagonal matrix? Yes. Because all the elements except this principal diagonal elements are zeros. So we reached up to which one? Diagonal matrix. Now the question is, for this diagonal matrix, is there any speciality to the principal diagonal elements? Yes. What is speciality? They are all equal. In the previous example they were different, -175. But here, all the 3 principal diagonal elements are same, 3, the absolute constant 3. So what is the principal diagonal elements here? Equal to the constant. All the principal diagonal elements are equal to a constant 3. All the principal diagonal elements are equal to a constant. All the principal diagonal elements are equal to a constant. And we said constant more mathematically means what? Scalar. That is what is in the very beginning. Magnitude is a constant. Okay, so the meaning is here all the principal diagonal elements are equal to a constant, but so it is a unit matrix. Why it is also known as identity matrix? Because this matrix is the identity element of multiplication of matrices. Clear? Okay, so we just recall the different types of matrices we have studied today, and thereafter we wind up today's session. Okay, first of all we studied what is meant by a raw matrix. What is it? A matrix having only one row is known as a raw matrix. Thereafter, column matrix. A matrix having only one column is a column matrix. And thereafter, we raised an important question. Is it possible to get a matrix that is a row as well as a column matrix? We said yes. A matrix having only one element is an example for a row as well as a column matrix. Okay, and thereafter we discuss what is meant by a square matrix. We said square, so related to dimension. So number of rows, number of columns equal. So we said a matrix having equal number of rows and columns is known as a square matrix. Then in square matrix, we set off which one? The diagonals. The diagonal from the left top to the right bottom is the most important diagonal. So it is known as the principal diagonal, or the major diagonal, or the main diagonal, or the primary diagonal. And thereafter the other diagonal from the left to bottom, okay, call it as what? The minor diagonal or the secondary diagonal. And the elements falling on or coming on the principal diagonal are known as what? The principal diagonal elements, or simply the diagonal elements. And thereafter, we have seen the importance of the row number and column number of the principal diagonal elements. What was it? Row number and column number are equal. In short, if Aij represents a principal diagonal elements, then I is equal to j. Okay? And thereafter, we have discussed what is meant by a diagonal matrix. What was it? A diagonal matrix is a square matrix in which all the elements except the principal diagonal elements are 0. Okay? And thereafter, we discuss what is meant by a scalar matrix. A scalar matrix is a diagonal matrix in which all the principal diagonal elements are same and equal to a constant. Then we discuss what is meant by a unit matrix. What we said, a unit matrix is a diagonal matrix in which all the principal diagonal elements are equal to unity. Means all the principal diagonal elements are equal to 1. Okay? And we said the unit matrix is also known as an identity matrix because later on when we discuss matrix multiplication, we will see that unit matrix is the identity element of matrix multiplication. Okay? Clear? So let us wind up this, and not giving any special assignment because now we are dealing with pure theories, but from the textbook, just go through the definitions and make it very clear. Because as I mentioned in the very first class, even though these definitions will not be asked in the examination, these are the fundamentals, the ways for building up our vast knowledge in matrix. So for proceeding further, it is very much necessary to be clear with all these concepts. Okay then, bye for today.